All right, today we are diving into a piece of technology that for decades, most computer scientists would have just straight up told you was impossible. We're talking about a database that seems to break the fundamental rules of how we build massive, global systems. Google Cloud Spanner.
You see, for as long as we've been building applications for the internet, developers have been stuck with this really frustrating choice. Do you want your data to be perfectly 100% consistent everywhere? Do you want your app to always be available no matter what? Or do you want it to scale up to handle millions of users all over the world? The rule was always pick two. That's it. You could never have all three.
This whole dilemma actually has a name. It's called the CAP theorem, and it's basically one of the bedrock laws of computer science. It says that any system that's spread out across multiple computers, which is pretty much everything these days, has to make a sacrifice. It's been treated as this unbreakable, fundamental truth of the universe.
And because of this rule, the database world kind of split in two. On one side, you've got your traditional SQL databases. Think about what your bank uses. They chose consistency above everything else. Every single transaction is perfect and in order, but man, they really struggle to scale globally. On the other side, you've got NoSQL databases. These were built for the modern internet. They chose availability, so they're always on and can handle just massive amounts of traffic, but they do it by giving up that strict, immediate consistency. But then, what if a database just refused to play by the rules? That is the incredible claim of Google Cloud Spanner. It was designed from the ground up to give you that rock-solid, perfect consistency of a traditional database, but with the mind-boggling global scale and uptime of a NoSQL system.
Okay, so how on earth is that even possible? I mean, if the CAP theorem is a law, how does Spanner just seem to ignore it?
The answer is one of those things that's both ridiculously simple and at the same time breathtakingly complex. It all comes down to mastering time itself.
Okay, so the secret sauce, the magic at the heart of all this, is something called true time. Inside Google's data centers all over the world, they have their own GPS receivers and their own atomic clocks. We're talking about the most precise timekeeping devices on the planet. This whole setup creates a single globally synchronized clock. A single source of truth for what time it is everywhere on Earth all at once.
And this is the absolute genius of it. True time doesn't just give you a single time. It gives you a tiny interval. It can tell any server, hey, I don't know the exact picosecond, but I guarantee the true real time is somewhere inside this tiny 7-millisecond window. That little window, that bounded uncertainty, is the secret weapon. It's just small enough that Spanner can look at two events that happened on opposite sides of the planet and know with absolute certainty which one came first.
This incredible ability to perfectly order events unlocks what is basically the holy grail for distributed systems, something called external consistency. So what that really means is, if you update your app's data in London and a millisecond later someone else updates it from Tokyo, Spanner guarantees that every single person everywhere in the world will see those two things happen in the correct order, every single time, no exceptions.
Okay, a global superclock is, yeah, it's incredibly cool from an engineering perspective, but so what? What does this actually let you do in the real world? What can you build when you have this kind of power?
Well, for starters, you get reliability that is just mind-bending. For its multi-region setups, Spanner offers what's known as 5 nines. That's 99.999% availability. To put that in perspective, that means a maximum of about 5.5 minutes of downtime over an entire year. It can do this because it's copying your data across continents, and if a whole data center region goes down, it just automatically fails over in seconds. And then there's the scaling. It just scales endlessly. It takes your data, breaks it into these little chunks called splits, and then copies those splits all over the globe using a really clever algorithm called Paxos. As your app gets more popular and your data grows, Spanner just automatically makes more splits and spreads them out over more servers. You don't have to lift a finger. It just grows with you.
So, you might be thinking, who actually needs this level of power? Well, think about the really hard problems. We're talking about financial services that absolutely cannot get a transaction out of order. Global video games where a player's items have to be exactly the same whether they log in from the US or from Europe. Huge e-commerce sites that need one single real-time view of their inventory so they never sell the same item twice. These are the kinds of mission-critical apps where Spanner really shines.
And maybe the most amazing part? After all that crazy futuristic tech we just talked about, the atomic clocks, the global synchronization, you know what developers get to use to talk to it? Good old-fashioned SQL. All the powerful queries and joins that people have been using for decades are right there ready to go. Except now, they operate on a planetary scale. But come on, we all know there's no such thing as a free lunch, especially in the world of engineering. This kind of power has to come with some trade-offs. So what's the catch?
There are really three main things to think about. First up, the big one, cost. This is a premium, top-of-the-line service, and it's priced like one. Second, you've got write latency. If you need to guarantee that a write is consistent between New York and London, well, you have to obey the speed of light, and that round trip introduces a tiny, but sometimes noticeable, delay. And finally, you have to be really smart about how you design your data structures to make sure you're getting the best performance.
So what Spanner really does is prove that that old choice, consistency, availability, or scale, might not be a choice we have to make anymore. It's a huge shift in thinking. And that leaves us with a pretty massive question to chew on. As our entire world gets more and more connected, is the future of all of our important data going to be built on the foundation of a single, perfectly synchronized global clock?